Hey everyone, welcome to another edition of ChatLoopBackOff. I'm Libby Schultz with CNCF, and today we have CNCF Ambassador, I'm going to mess it up, Oluebube Princess, who is going to explore Copacetic for the first time. Please correct me because I'm sure I probably butchered your name.
You actually pronounced it correctly.
All right. Oh, I'm excited. Okay. Well, take it away, and thanks for joining us today, everybody.
Awesome. Hello, everyone, and welcome to this session. Thank you for tuning in. Today, we're going to be exploring Copacetic together. A little about me: I am Bube, as Libby has already said, and I am a software and DevRel engineer. You can also catch me doing some things on the cloud, maybe once in a while. Most importantly, in the context of this session, I am a CNCF ambassador, which is an extension of the Cloud Native Computing Foundation. And the goal of the CNCF ambassadors is to make cloud native ubiquitous. Um, that being said, if you have any questions, you can drop it in the chat and we'll look at it together when we are ready for that. So I'm just going to share my screen and take it away. Awesome. So what exactly is Copacetic? So I have two screens and I'm going to be looking at the screens interchangeably. So bear with me. First of all, would start with the why. Traditionally, when you find maybe a vulnerability in your container, the traditional thing to do is to, go to your code, try to fix it, import a new image, if need be, rebuild it, and then redeploy. So I like using the docs as a reference because, it's the most, in my opinion, like the documentation for any tool contains the most information that you'd need for that tool. So, why copacetic? So from the docs, we can see we need the ability to patch containers quickly without going upstream for a full rebuild. So with copacetic, we are trying to avoid going through the entire process of rebuilding an application or rebuilding a container rather. Um, just a second. So let's say you find a dependency vulnerability using a tool like Trivy, which is a scanner. What you typically do is to fix it and then rebuild your application and deploy. And Copa's solution is to patch these security vulnerabilities in your containers without having to rebuild them. So Copa is a CNCF project, is a CNCF sandbox project that's used to patch container images. That's basically what it is. Why or the advantages of using Copa? So it allows users other than the image publishers to patch container images. So if I use a tool like, let's say Alpine, for instance, or Nginx, which is the example that is on the documentation, if I use that image in my application and there's a vulnerability, I can just go um, patch it without having to wait for whoever the maintainer is or the image publisher is. And then it also closes the turnaround time, between when a vulnerability is found and when it is fixed. So it says here, reduces the turnaround time for patching a container image by not having to wait for base image updates. So sometimes these updates can take maybe up to 4 months, 5 months, depending on who the image publisher is and how important it is to them to fix it. So if you leave this, it can potentially introduce other vulnerabilities in the software supply chain. So I think this is a very good advantage of using Copa. It also reduces the complexity of patching the image from running a rebuild pipeline. We're going to see this in detail much later. So as opposed to just rebuilding the entire thing, you just patch an image and then redeploy. So how does Copa do this? So from the diagram here, we see that we have a container image. We have an application image here. So we use a tool like maybe Trivy to scan this image, and then Copa passes the reports that's generated from the application image scan, and then it passes it and creates a patch diff on top of the file system, and just patches the application image by adding a patch layer from the pass that it has done here. So we're also going to see this in practice rather. So here it also goes further to talk about, again, the advantages of using Copa. Copa supports patching existing container images. So devs don't need to build their own images. So if you have an image that you're using already, you don't have to build your own image. Copa supports containers without package managers. Okay, for this is for distroless containers. For containers that are like lightweight containers that only contain what you need, what an application needs to run, like it doesn't, not the heavy containers. So Copa also supports that. It works with existing vulnerability scanning and mitigation ecosystems. So it actually plugs into currently existing ecosystems for vulnerability scanning and mitigation. And finally, it says here, it reduces the technical expertise. In my opinion, like I actually went through Copa today, and in my opinion, I think that you don't need a lot of, this is especially true, you don't need a lot of technical expertise to be able to use Copa to fix these vulnerabilities. So we're going to go to the next thing, which is installation. So for you can install Copa using Brew. So Brew install Copa. There's also an option for installing it manually. So if you'd like to do that, you can actually go to Copa's documentation and try to do it. A few of the prerequisites: you need to have Go installed, you need to have Docker installed, and you need to have Trivy installed as well. So I'm just going to, so I have this Go version. I have Go installed already. I think I have Docker too. Docker version. What else? I think I have Trivy as well. Trivy. Yep. And I've also gone ahead to install Copa. So okay. So it's Copa version. Okay, so I have Copa installed as well. So prerequisites here, it says you need to have Copa tool. You also need to have build kit. I'm going to explain what build kit is. You need to have Docker installed, and you need to have Trivy. So Trivy is the scanner that we're going to be using. Okay, and here we have sample steps. So before patching your image, you need to specify a build kit instance to connect to. Um, okay, we're going to run this also in practice. And then after that, you need to scan the container image to check for patchable OS vulnerabilities. And then you go ahead to patch the image. And finally, what else? You scan the patched image to verify that the vulnerabilities have been patched, and then run the container to verify. Okay, so I'm just going to go to the CLI and then try to do all these things one after the other. So in the documentation, the image that's used is Nginx 1.21.6. So you can just export this image as is here, or you can go ahead and download the image. I typically like to download it though, so I'm just going to do Docker pull Nginx 1.21.6. That might take some time depending on the number of factors. So a little bit of patience while this Docker image is pulled from the registry. Okay, and once we have that, we're going to use Trivy to scan this container image. So something to note is that um, for Copa, we focus mostly on the OS, right? So containers are lightweight, like they're built on lightweight operating systems, and even application containers typically include a base OS layer like Ubuntu, Debian, Alpine. So any vulnerability in these layers can introduce security risks to your entire software supply chain. So Copa primarily targets OS package managers like your APT, your YUM, and it is optimized for handling OS level vulnerabilities. So we're not going to be focusing on other vulnerabilities. We are going to dwell mostly on OS vulnerabilities, which is what Copa focuses on. Other language level vulnerabilities are more complex because they have like a lot of dependency trees that are managed by specific language ecosystems. Like you have your Python pip or your JavaScript npm. So they have their own language ecosystems. So Copa does not manage those. Like it primarily targets OS package managers. So we're going to scan the image. Yeah, it's downloaded now, or it's been pulled. So we're going to use Trivy to scan this image. And like I said, we are going to be focusing on OS vulnerabilities. So vulnerability type, OS, and then the image that we're going to be scanning is Nginx 1.21.6. So I'm just going to run that, and it's going to list out the vulnerabilities that this particular image has. Again, a little bit of patience, might take a minute or more. So while that is being downloaded in the background, um, okay, I think we need to wait for that because it's important. So as soon as this is done, you're going to see all the vulnerabilities in this image, and we're going to use Copa to fix all those vulnerabilities. 94%. Here we go. Yeah. Oopsie. So, okay, this is a lot. So I'm just going to um, I'm just going to get the total number of vulnerabilities. So if you look at this, you'd see the vulnerabilities that this image has. So it has 21 critical vulnerabilities. It has 94 high, 122 medium, 20 low, and one unknown. You can imagine running your application based on this image and the kind of vulnerabilities that it might introduce into your software supply chain. So now that we have that, we've seen these vulnerabilities. Copa needs to patch your image, or Copa needs to patch your image by passing these vulnerabilities, right? So somehow it needs to find these vulnerabilities somewhere. So we need to save these vulnerabilities into a file that we're going to pass into Copa that it's eventually going to use to fix the image. So um, I believe the way to do that is to okay, just put the output of this into a JSON file. Ignore. Okay, yeah. So the output of this vulnerability scan is we're going to put it in a JSON file, nginx 1.21.6.json, and again from our image, the one that we have already. So I'm just going to run that. And if we do an ls, we would find the file that contains the result of this vulnerability. So let me just open that quickly. And you can see like it has all the results of the scan here. Let's just zoom in on maybe one of them. Um, Posts following put confusion. When doing HTTP transfers, libcall might erroneously use the read callback to ask for data to send. If the same handle previously was used to issue a put request, which use that callback, this flaw may surprise the application and cause it to misbehave. So this is one of the vulnerabilities, and this is a critical vulnerability. If you keep scrolling, you'd find like a bunch of others, but that's not what we're focusing on. I just wanted to show us the results of the scan. Now that we've scanned our image, like the documentation said earlier, we need to, before patching your image, you need to specify a build kit instance. So if you don't specify a build kit instance, Copa will not Copa. So let me explain what build kits, like the essence of build kits in this case. So Copa modifies a container image by creating a patch layer without necessarily rebuilding the entire image. So build kit allows Copa to apply your file system changes efficiently by adding that diff as a new layer on the existing image. So that's the essence of build kit. So by default, I think build kit is the default build engine for Docker. However, you can also run it as a standalone service, and we're going to be running it as a standalone service. So I am going to do a Docker run, and I'm going to do it in a detached mode so that it runs in the background. And we will also remove that as soon as the container stops running. And we're going to be running it in a privileged mode in local hosts on port 8888. And the name of the container that we're going to be running is build kitten. I mean, you can call it anything that you want to call it. And the entry point is also build kitten. Again, what you want to call it. From the image, from this particular image, build kit version 0.11.6. So this is the build kit image that we're going to be running, which Copa is going to use eventually to patch the image for us. Again, this might take a bit, so I don't have this locally, so it's going to try to download it. Mm, not sure why it's taking more time than. Can everyone hear me? I mean, please, can you leave a comment in the chat if you can hear me? Oh, awesome. Thank you. Um, I was initially wondering why it didn't start the download or pulling Mobi. So, um, this is pulling the build kit image that we need, and we're just going to wait for that to finish because we need it to run Copa. If it's not there, like there's nothing that Copa is going to hold on to. So just a few minutes. Okay, back to the documentation. Mhm. Okay, scan the image. We've done this. Okay, so this is what we're going to do next. We need to use Copa to patch the image that um, we scanned. So just waiting for this to finish. Okay, I'm really sorry. My I think my internet is not strong enough. That's why it's taking some time, but we're making progress. So just wait for that for a few more minutes. Mhm. Um, okay. Is my screen visible though? Like on the live video, like can you see the terminal? Okay, I can't see the terminal like my CLI. Oh, it's not visible in the screen share. Oh no. Okay, I'm just going to stop sharing and try sharing again. Awesome. Oh my God. So I think I'm just going to have to redo everything that I did on the CLI. Okay. Is it legible though? Awesome. Thank you. So I'm just going to do everything again from the beginning. So the first thing I did was to pull the Nginx image that we were going to scan. So Docker, I did a Docker pull Nginx 1.21.6. And then after that, I did a Docker images to make sure that the image was downloaded. So as you can see here, we have the Nginx image that we're going to scan. And then I did a Trivy image. I did a Trivy image scan to see or to look at all the vulnerabilities that are contained in this particular image. So you can see 21 critical, 94 high, 122 medium, and so on and so forth. And then the next thing I did um, was to send the result of this vulnerability scanner to a JSON file, which is going to be passed by Copa. So we need we need the output of this scan to feed it into Copa so that it can create the patch diff and then apply it to our container or our image. So how I did that was I did a Trivy image. Yeah. So here we go. So this is where I saved the result of the scan that we just did. It's in an Nginx .1.21.6.json file. That was what I did. And I'm going to show you the output of that. So if you do an ls, you'd see the outcome of this scan and the outcome of that result that we did. So I'm just going to open it so that you can see what's contained inside. So it's a JSON file that details all the vulnerabilities that are contained in the image. So you can see the title of this one is Unpreserved File Permissions. When you do a call, um, when when call this address, when call this address saves cookies and hosts data to local files. It makes the operation atomic by finalizing the operation with a rename from a temporary name to the final target file name. In that rename operation, it might accidentally widen the permissions for the target file, leaving the updated file accessible to more users than intended. And this is a critical issue. I really feel sorry that all the while that I was explaining, we weren't seeing this. I'm really sorry about that. So are we together at this point? Okay, thank you. So the next thing to do after we've scanned our image and we've gotten the output of this vulnerability scan, the next thing to do is to run build kits. And I've explained what build kit is. I also started running build kits by doing a Docker run. I was trying to run build kits in the background. Mhm. Unable to stop stats. Okay. Um, okay. Just give me a second to copy that again from documentation. Okay, so right now if we do with Docker PS, build kit should be running in the background. Are we together at this point? Okay, this was where I stopped. This was where I was until I discovered that you weren't seeing my CLI. So now we have build kits running in the background, and we can go ahead to use Copa to patch our image. So I'm just going to run a Copa help, and we can see the commands and the flags that we can use. So I'm going to do a Copa patch, and I'm going to feed the result of our vulnerability scan into this command that I'm going to run right now. So Copa patch. Um, so we are trying to patch the Nginx image that we just scanned, and the report that we are going to scan from is, or that we're going to patch from, is the JSON file that we just created, and we're going to tag our new image 1.21.6 patched. And then this is just build kits, the build kits that it's going to use to run this patch for us. Thankfully, this one is running very quickly. So this is almost the last step on the documentation. Again, everything that I've done is on the documentation, and you can just do a copy paste to your CLI. This is taking some time, just a few more minutes. Okay, let me just show the documentation again. Let's go back to the documentation. So this is the step that we just, this is what we just ran now. And then, okay. Okay, this is the step we just run on our CLI right now. So as soon as that is done, this is actually the patch, the last phase, which is the patch step. So as soon as the patch is done, you can scan the patched image to see if there's any vulnerability. So I'm going to share my CLI again to, okay, that's done. Back to the CLI. Okay. So this is done running, and our Nginx 1.21.6 has been scanned. So we're going to use Trivy to scan this image again to see, sorry, we're going to use Trivy to scan this again to see if it is actually, if it actually fixed the vulnerabilities that we discovered earlier. So you can see there are no vulnerabilities anymore. We don't have any vulnerabilities. Just for clarity, let me just do a grep total. Right now, we do not have any vulnerabilities. I don't know if there's any question at this point. Is there anything that was kind of confusing? We can actually go through it again on the documentation. So from the documentation, it says that we should run the container, that's the one that we just patched, to make sure that the image has no regressions. So I am going to, oopsie. So I am going to run, is my screen visible? Am I online? Okay. So we're going to run this image. Okay, according to the documentation, we can run this image to make sure that it actually still runs, right? So I'm going to run this. I'm just going to open another. Yeah, and we can see our patched image running. So everything is up and running. There are no issues. I can close this now. So I don't know if there's any question at this point. So the rest is actually maybe just going through the documentation to see recommendations from the Copa team. So I'll just share the documentation again. Um, and there you go. So we just ran our patched image and everything works really well as expected. So that's it. So the next thing on the documentation is actually tagging guidelines. Mm. I'm really sorry about like my screen taking time to show. I don't know if it's the internet connection or something. I don't know what it is, but please bear with me. Um, I'll just try sharing it again. Please let me know when you can see it. Thank you. So as I was saying earlier, like we just went through this entire steps on the CLI. And right now, the next thing that we want to look at is the tagging guidelines. So for tagging guidelines, Copa, there are different tagging guidelines. So there's the static incremental tags, where you just maybe increment your tags from 24.0 to 24 point, um, okay, 24.0 hyphen 1 to 24.0 hyphen 2 to hyphen 3 and so on. And then you just keep increasing it that way. And then there is also the dynamic tags, where another option is a static tag that is continually reused as new patches are applied. For example, you could have an initial unmodified image that you've tagged 1.21.0 hyphen 0. In this case, hyphen 0 at the end helps identify the base unpatched image. So you could use this to represent your unpatched image, and then as you patch, all following patched images are then tagged as 1.24.0. You then know that the one tagged image always has the latest patches. I'm not sure I understand what this means, but I mean, anyone that understands it can please try to explain in the comment section. But I really understand this static incremental tags, which is very traditional um, in software engineering. Like this is what we use mostly. I am not sure that I'm clear on this one. And then there's dependabots. Dependabots can create PRs to update image versions to Copa patched versions. So by default, if no update type is specified, so if you do not specify, I'm guessing in this case, whether it's static or dynamic, dependabots will be able to bump from a non-revision version to a revision version of an image if it exists. For example, from 1.2.3 to 1.2.3 hyphen 1. And really, that's it about Copa. So I think the next thing is troubleshooting common errors that you're going to encounter when trying to run Copa, and then the rest is frequently asked questions. So I don't know, based on what we ran on the CLI, I don't know if anyone has any questions. I can try to answer that and would call it a day. Anyone?